In this tutorial, I'm going to illustrate how to fit a simple linear regression model using SPSS. And again, we're going to use the roller coaster data set where our explanatory variable is the height of the drop in feet, and the response variable is the speed of that descent in miles per hour. So having already looked at the correlations and the scatter plot for this example, we can feel relatively confident that a linear model is a sensible thing to do. So to do this, we click on Analyze and go down to Regression. And since we're trying to fit a linear model, we click on Linear, and this will pop open the initial script that we need to use in order to fit the simple linear regression model. The first thing we can do is slot in our dependent variable, or our response variable, which is for us is speed. Now in simple linear regression, we'll only have one independent variable or explanatory variable, and that is drop. Having entered in those, we don't need to specify any other options. Everything should be there by default, so all we need to do is click OK. SPSS returns more than we really need in Math 207 for simple linear regression at this point in the course. So let's just go over the output that's produced by SPSS. So let's start with the model summary box. We can ignore the variable entered removed section in the output. Under model summary, we're only really going to look at two pieces of the output. The first is R, and that's going to show the correlation between the two variables. And you can see that that matches the correlation we obtained the alternative way. The second quantity that we're going to look at is R squared, and that's going to give us the proportion of the variability in the response that's going to be accounted for by the simple linear regression model. Next, we're going to come down here and look at the ANOVA table. Now the ANOVA table isn't labeled exactly like it is in our book, so we need to remember a couple things. First of all, ANOVA is going to give us our sums of squares. So when you look at this model column in this table, these are all types of sums of squares. So the sums of squares total is SST, and that's defined in our book. So if we ever need the sums of squares total, we know where to look. The second piece that we want to look at is the sums of squares error, which SPSS labels as residual. So if you need the sums of squares error, go to the residual row and look at your sums of squares. Last, and most interestingly, we're going to look at the regression coefficients, which are in this coefficients table in SPSS. Now, SPSS doesn't label things, again, exactly as we want them to, but it's pretty easy to remember. This constant is the intercept, so if you go to the unstandardized coefficient, which they label capital B, our book would label beta hat or lowercase b, that's going to be your estimated intercept. Under drop, or if you have a different explanatory variable, whatever that variable name is called, that's what will be in the second row of the table, and that's going to be the estimated slope for this regression model. I think that wraps everything up that we would need from a simple linear regression fit at this point in the course.